this was like supposed to be the last part of that activity. So yeah, don't write this down. Don't worry about it. But I want you to follow. Make sure your phones are away. Make sure your eyes are kind of up and you're watching. This was supposed to be the last part of it. It's hard. And we said this a lot yesterday. This is not, and you guys did a great job. Like I was saying, this is not stuff I would actually expect you to be able to do, and then you did pretty much all of it. So that's really good. Now, we didn't do it always in like with equations and algebra, but we figured out the answers, right? So that's fantastic. And this is, again, one that I would never expect you to be able to do this today, but I just want to show you how a question like this that's a bit more complicated, but we can still use our intuition to solve. But if you understand a little bit about math and some of the formalities of it, it can help you solve it even a little bit more. It can kind of make some structured sense of what you're doing intuitively, like in your brain, right? Without doing it the math class way. Okay, so we're saving for an item that costs $800. You have 130 in the bank, and you make 40 each week, but you spend 12 each week on the bus getting to your job, I suppose. How long will it take you to save for the item? So here's what we have. You've got some money. Every week, you make a little bit of money, but you lose a little bit of money. When are you going to reach that destination of $800? We were working with $500 yesterday. What costs $800? Some of the same things we talked about, like laptops and stuff, if you buy a fancier one. Anything else? Rent. If you have to rent your own apartment, it would be $800 every month. Yeesh, that would be tricky. You wouldn't make enough $40 a week. Okay, so let's take a look. There's a few different ways that you could do this. I'm going to just, so don't write this down, just watch. But I could do this. I could do 800 minus 130, because I've already got the 130. What's that going to give me? I'm not going to actually write down that answer, but anybody know? 670. Very good. So I only need to make, that's my actual goal from where I'm starting is 670. Okay? But I'm going to, so then I'm going to do, let's say for now just plus, I'm going to get 40 each week minus 12 each week. That should, I'm going to change that from a plus. Does that make sense? The W is just how many weeks goes by. That was that question mark that we were talking yesterday. This is not something that I would, like if it doesn't make sense, that's okay, because we haven't done this yet. But it looks like math class math, doesn't it? Okay? And it starts to feel complicated, but it's still just that idea of that intuitive, like you have some intuition on, well, if I make $40 a week, but I lose $12 a week, how much am I actually making every week? 28. So this is actually 28 every week that you're going up by. Does that make sense? That's algebra. That's collecting like terms. That's something that people have a really hard time with. But sometimes when you kind of, like, when you think about it, it's maybe not that bad. If it is that bad, if you're not following, again, like I said, that's fine, because we're going to learn all of this basically from scratch. And then how would I solve this? How do I figure out how long it'll take me to make $670? Because that's how much more I need to get to 800. If my net profits after all the money I spend, I make $28 a week, I'm going to divide. So I'm going to divide, and if you were doing this the math class way, you divide both sides by 28, okay? And I get my calculator out, and I would just go 28 divided by, 670 divided by 28, and it gives me 23.9, almost 24. So it's about 23.9. So 24 weeks, which is a long time. That's almost half a year to save up for that. So that's just like, from that little activity we did yesterday, we weren't really doing formal math, but it does show us how, if you know a little bit of formal math, it can actually help solve harder questions. We can usually solve the easy ones just in our heads, but the harder ones sometimes you need a little bit. But it's just algebra. I make $40 a week. I lose $12 a week. $28. That's algebra. That's all it is, right? It's just that idea. But we'll look at that in a lot more detail down the road. Okay, so here's what I want you to write down. We're doing a lesson on Bedmas today. So you can write down the title. You can write down the learning goal if you want. You don't have to. And then we're going to finish the sentence. Bedmas tells us. So you probably know what Bedmas stands for. That's not what I'm asking yet. What does Bedmas actually tell us to do? What does it tell us? Cole? Sure. Yes. One key word you said there. What was the most important word that you said there? Do you know? No, that's fine. Does anybody else know? Order. The order that we do things in math, basically. That's exactly what it does. The order of the letters is telling us the order. So Bedmas tells us the order we do, and I'm going to add a word to this, operations. What are operations? Kind of. There's a little bit more to it. Can anybody name an operation in maybe you've never heard that word used this way before, I don't know. Wild guess. Not quite. Like multiplication, division, the things in there, adding, subtract, those are mathematical operations. That's all. If you don't know them by that term, that's fine. You don't need to. I'm never going to test you on that. What are adding and subtracting called? Operations? No. We don't do stuff like that. Yes? No. Operations are what are we talking about? That's okay. It's okay. I thought you had a question. Okay, so now I want don't shout it out too much because maybe we'll get a few people to dive in here. But let's talk about what they actually stand for. You want to give me the first one? Brackets. Next one is a bit of a tricky one, Cole. Very nice. You do a lot of exponents in elementary school? Did you do a lot of exponents in grade 7 and 8? Yeah? Good. Do you remember much about them? No? Okay. Okay. Ethan, do you want to give me the next one? Very nice. Division. Next one. Do you know it? Multiplication. Very good. See, you guys know this stuff. Something special about division and multiplication. Do you know what it is? Remember, Bedmas tells us the order to do things. But there's a catch for division and multiplication. They actually happen at the same time, sort of. So we'll do division and multiplication, not always dividing first, but we do them left to right. Okay, so together, left to right. Whoops, spelled right wrong. My gosh. See, it is a new semester for me, and I'm getting warmed up too. So don't worry. Don't feel like you have to be top of your game yet. Okay, A, somebody else? Lauren, do you know what the A stands for? Think about it for a second. See if anything comes to you. Who said that? Okay, try not to yell out. Tariq, right? Thank you. That's awesome. You're right. You didn't answer one yet anyway, so that's okay. Emma, do you know the last one? Subtraction. Very nice. Subtraction. So there you go. The order that we do things. There are some exceptions, and this is where some people start to have a hard time with math, is like, if the question is simple, we can just use this. If it's a really complicated question, sometimes it gets a little bit harder. There's different ways of doing things, or in some different kinds, like when we're solving equations, things look a little different. But really, this is the way that we do things. When do we use Bedmas? This is a bit of a trick question. When do we use Bedmas? You want to try? You're exactly right. Whenever we do anything, we always use Bedmas. I make a big deal out of this, and I'm going to do this always. Because throughout this, and if you ever ask this question, it's fine. Like, it's not a big deal. But throughout, courses and semesters, I get students who say like, do we use Bedmas for this? Yes, you use Bedmas. What do you mean do you use Bedmas? You always use Bedmas. Bedmas is math. That's how we do everything. You always use Bedmas. Even in things like solving equations where it looks like you're not using Bedmas, you are using the rules of Bedmas. Okay? Everything you do. You could be a university math student doing that crazy math that you see on TV and stuff. You still use Bedmas for everything. Algebra, graphing, like everything, I'm telling you. Okay? So we always use Bedmas. But it's not always obvious exactly how we use it. Okay. You don't have to write this down. So just watch, but I do want you to watch. Okay, but you don't have to write all this down. This is a little bit of a demonstration. Remember this from yesterday. You have $80 in the bank, and you make $30 per week for 9 weeks. So watch what happens. I have $80. So I've already got that. I'm going to add $30 per week times 9 weeks. How do I answer this question? What operation or what order do I do those operations? Because there's 2 ways that you might answer this question. Julia.
So first you would multiply the 30 times 9.
And why did you do that?
Because then you have to figure out like how much in the end.
Yeah. Why did you multiply first though?
Because.
Good job. Because of Bedmas, right? So what is 30 times 9? Use a calculator. Anybody got a calculator? You can try to do it in your head, and if you can, that's phenomenal. But don't worry too much about that right now. 270. And what's 80 plus 270? Close, 350, I think. Very good. Good job, guys. That's good mental math. Even if you didn't quite get it, that's really good. Okay. So I think that's the right answer. What did the question say? It says you have $80 in the bank, and then you make $30 per week for 9 weeks. $30 per week for 9 weeks is $270. And you already had 80, so you add that in. What if I did this question wrong? Okay, remember, you don't have to write this down. What if I did it wrong? What if I did 80 plus 30 first? What's that?
You still get the right answer.
Do you?
Yeah.
Let's find out. What's 80 plus 30? Good. So I'm going to do 80 plus 30 times 9. So 110 times 9. What's 110 times 9? 110 times 9. Close. 990, right? You don't get that last 9. But good. Not the same. This is why Bedmas is important. Because if you follow Bedmas, you're going to get the right answer. If you don't, you're going to get the wrong answer. But more importantly, what did this all mean? It's saying I got $110 per week for 9 weeks. And that's not what we got. Right? We got $30 per week for 9 weeks. And we added in 80. We didn't get $110 for 9 weeks. That's why it's wrong. It doesn't match what we did, what we were talking about. Does that make sense? Now, don't write this down. I'm going to show you one more little thing. This, folks, this is not stuff you need to be able to do right now. Like, we're not doing word problems yet. But again, we're exploring why, like, this weird thing about math, how you have to write it a certain specific way or things don't work out. Why is that? And why is Bedmas important? And why do we have all these complicated rules for how we write things? And why do we have algebra? Like, why do we have equations? right? Okay, so let's take a look at this one. Now, a different situation. You have two jobs. From one job, you make $80 each week, and from the other job, you make $30 each week. How much will you have after 9 weeks? It looks similar, doesn't it? What's the difference? Ethan? So what's it gonna work out to? You're gonna have two totals in the end. I love it. Let's do that. So I'm gonna get $80. Whoops, that's the wrong thing. I'm gonna get $80 per week for 9 weeks, plus $30 per week for 9 weeks. Ethan, I didn't even think about doing it this way. This is fantastic. That's a different kind of BEDMAS question. I love it. So 80 times 9. Does anybody have a calculator? You can do that? Noah, don't you have a calculator on your phone? You find that and help work that out? Do you? 720. Noah, do 30 times 9 on your calculator. So 720. 9 times 9.
270.
Wonderful. Somebody add those together. You can keep it out. Add them together. What'd you get? 990. Do you remember that number? Tariq, remember that number? 990. It was the same as when we did 80 plus 30 first and then multiplied by 9. Okay, this is where it starts to get kind of weird. And again, we're gonna be done with this in a minute, but take a look at that. This says 80 plus 30 times 9. This one says 80 plus 30 times 9, but what's the difference? It's in brackets. So in this case, we're adding first. In this case, we multiplied first. And they represented different real life situations. This one is you've saved $80 and you're adding to it. This one is you've got two jobs. So my two jobs together means I make 110 per week total for 9 weeks. Does that make sense? It's interesting how you could actually take some of this school stuff that you do like BEDMAS and then actually sort of apply it to the right kind of a situation. And it starts to make some sense why we have brackets, why we do different things in different orders, when you would want to. And you have some intuition about that. Like for both of those situations, you probably could have worked out the answer to it. But maybe not the math class way that we're supposed to do on tests. Okay, so that's what we're going to work on. So I want you to write this down. We're going to start doing a few examples. So write down the question. I think we're only doing one example, but instructions say evaluate. That just means answer it. Write down the question, and when you don't have to answer it. We're going to answer it together. So if you've already started answering, stop. Put your pencil down. Just watch. Okay. Do you think we should use BEDMAS for this question? I think so, right? We always use BEDMAS, but this is the kind of question that looks like a BEDMAS question, right? Like it looks like the ones that you get when you're talking about BEDMAS. So we're going to worry about the order of operations. And I'm going to show you something. So don't copy this down. I just want to show you something. It's interesting how our brains sometimes try to play tricks on us. And even though you all know BEDMAS, and you know that it's the order that we do operations, you know that we multiply before we add, and we really don't add until the very end, a lot of people on the test are still going to do this. What did I do wrong? I added. And there's all kinds of other stuff I was supposed to do before I added. Why do we do that? Even though I know I'm not supposed to, why do I do it anyway? What do you think? Yeah, maybe. Good. That's a good point. Any other reasons why maybe? Yeah, your brain is trained to read left to right. And I think there's a bit more to it. 5 plus 2 is really easy. And the number 7 jumps out when I just see that on the page. And I'm like, I know the answer to that, and I write it down. And I sort of just start going too fast. I don't slow myself down to think about Bedmas rules. So really, you got to be careful, because even though I warned you about this trick, and I'll tell you right now, there will be a question on the test like this, or quiz or whatever, okay? And some people will still fall for it, because we just can't force our brains to slow down and use the rules in some cases. But that's part of learning. That's the whole reason why we do this stuff. So let me get rid of the wrong answer. The other thing is, this is a really good chance to start practicing good form and notation. So some people like to do their math across the page. We're going to try to go down. So we're always going to write our question and then work down every line below that. So if you already started writing out stuff, you can just scratch it out. Don't really worry about it for your own notes. I'm going to write the whole thing down. There's a lot going on in this question. What do you think we're going to do first?
10 minus 7.
Why?
Because it's a bracket.
Yeah, so we do brackets first, 10 minus 7. We're going to do that part first. So some people, again, don't write this down. They want to do this. 10 minus 7 equals 3. For easy questions, you might get away with that. But for longer ones, and when things start to get more complicated, you're not going to. Okay, it's going to really mess you up. So we're going to try to have good form. We're going to go 5 plus 2 and 10 minus 3. I'll put the answer in place of that part of the question from the line above. Noah, are you with us? Come on. You want to write this down? Get a copy of it. Okay, what are the operations that we have left? Tariq? We have 5 plus 2. What else? Do we have anything else? What about that 3?
2 times 3.
Why is it times?
Because it's in brackets, and then you got to multiply because
Yeah, that's good. You're right, though. Is that familiar to anybody else? That when you have a number right beside a bracket or 2 brackets right beside each other, it means multiply. That's something you need to know, because we often write questions like this. 5 plus 2 times 3. So which one do we do first? Caleb, what do you think? Bedmas. What comes first? Multiplication or addition? Good job. Got it. It's all you have to do is ask yourself that. You write Bedmas down at the top of your test and just keep referring back to it. Which one's first? Which one's first? Or as you're practicing, which one's first? Okay, so 5. What is 2 times 3? Shout it out. What's 5 plus 6? That's all we have left? 11. What do you think? Some people might think this is, well, that's brackets. So don't I do brackets first? That's a little bit of a tricky thing, but sometimes we have sort of brackets we use for different things. These brackets have an operation inside, so I have to do it. These brackets just have a number. They're just there to organize it and to show that it's multiply. You don't do anything with them. So again, just practice and try a few different questions, and hopefully that'll make sense to you. All right. What's going on in this question? Somebody tell me some of the operations and things that are happening. Like, somebody tell me one operation that's in this question. Lauren, do you see one in there? Any operation in there that you see? That's okay. What do you think? Just like operations. So multiplying, dividing, adding, subtracting. Adding, got it. Adding, perfect. Yep. We got subtraction. What else do we have? We have multiplying. Where's the multiplying? The little dot. That's a weird thing. That's not a decimal. That's not like 2.4. It's higher. And we see it once in a while. It's only here. You won't see it too much, but it's in this question on purpose to remind us, or if you've never seen it before, that a dot like that sometimes means multiply. Tariq? There's an exponent in here. And what else is in here? It's not really an operation, but it tells us what to do. What else do we have to think about? The brackets. We have almost everything. Adding, subtracting, exponent, multiplication, and brackets. So what are we going to do first? Cool. Brackets. How'd you answer that question? Bedmas. You look at that word, brackets comes first, right? Let's write the whole thing down. What's 5 minus 3? Damien, do you know what 5 minus 3 is? Don't forget the exponent. And then times 4. If you want to change that to an x, that's fine. Why do we use a dot sometimes instead of an x? Because when we get into algebra, we use x as a variable a lot, which we won't for a while. But you use x as a variable quite a bit. And it would be confusing if you had an x for variable and an x for times in the same thing, so that's one. What do we do next?
Exponents.
The exponent. Now, exponents are tricky, and this is a bad example. So let's go, I'm just going to go over here. You don't have to write this down, you can if you want. How do exponents work? Can somebody tell me what 3 to the 2, what it actually means? Tariq?
It basically means multiply it twice.
It is 9. Multiply it by itself. So what's the middle step that I would write? Yeah, good. So what would I write? 3 times 3. There's 2, not 3 times 2. Oh my gosh. There's 2 3s. So what would 4 to the 3 look like? Spencer, what do you think? Any clue? You take a guess?
4 times 7.
So 4 times 4 times 4. Now, what is it? You may not be able to do that in your head, but you don't have to be able to do that in your head. I don't want you to be able to do that in your head necessarily. Use a calculator for it. You just have to know it's not 12. Why would somebody write 12? Caleb, why do you think somebody might write 12? Do you have any idea? Huh? If you divide it, yeah. Yeah, same idea, right? 4 times 3 gives you 12. But it's not 4 times 3. It's 4 times 4 times 4. Your calculator can do exponents if you get a good one. If you don't have an exponent button, then you just do 4 times 4 times 4 on it, right? We're not going to see a lot of exponents yet either, I don't think. So this one is 2 times itself twice, which is 2 times 2. Alana, what's 2 times 2? 4. So this is 11 plus 4 times 4. What do I do next? What do I have left? Leah, what do I have left? Operations. I have to multiply next. I've got adding and I've got multiplying. Multiply first. What's 4 times 4?
16.
11 plus 16. What's 11 plus 16? 27. How are we doing? Okay, try this one on your own. Oh, yeah. Well, the way you're writing it is weird, but you ended up getting it right. That's okay. It's learning. How many people got 11 is the answer? What's the other answer you might have got? 20. Somebody might have got 20. Why would that be wrong? This is what people do. Remember, we have made a big deal about this. So this is wrong. Don't write this down. 3 plus 2. I know what that is. That's 5. 5 times 4 is 20. Your brain tricks you. Even though we talked about it and talked about it and talked about it. Your brain tricks you. So that's wrong. We don't want to do that. But what actually is it? This is multiplying. I want to do that first. So it's 3 plus 8, which is 11. Okay. I'm going to do, where'd it go? I'm going to do this one really fast. Don't even copy it down. You don't have to. Okay. There may be a few questions that look like this. What does the line mean? Division. So I got a bunch of junk on the top divided by something on the bottom. A bunch of junk on the bottom. So this is like, I have to do the whole top and get a number, do the whole bottom and get a number, and divide at the end. This is one of those tricks, because even though Bedmas says you divide before you do lots of other things, in this case, we can't do that, right? In this case, we have to get the top and the bottom figured out before we can divide. So it's almost like there's brackets that are invisible around the top and bottom. So what's 30 minus 10?
20.
2 times 2? Yeah. And now I have 20 divided by 4, and that works out to 5. So easy question, just a simple one to remind us what that looks like. Okay, here's the test. I want you to try this one, and I'm going to come around and pass out a worksheet for you to practice a few more. So we still got lots of time. And if anybody has that, you can get it out and I'll come collect it. And if you don't, then try to get it, for tomorrow.